For our demonstration, let's begin by bringing up an Express model containing some pre-generated diagnostics. In the design window is the Express model that has captured all the dependency relationships that we need in order to develop a set of diagnostics for any testing purpose. And here on the left you can see the diagnostics flow diagram, which is automatically generated within Express. What we're going to do is export the design's diagnostic information out of Express using the diagml export, which has been configured for a DSI Workbench export. Notice that there are several stock exports that are pre-configured for static dynamic reasoning, our simulation tool for stage, etc. And of course, this one here, Workbench Demo, is the one we're going to use. After we export our model, we'll need to save it in its proper location. But in this demo, we'll just use the My Documents directory. As we enter into the Runtime Authoring tool, let me point out that this is a tool that typically a technical writer or a system engineer would use to author diagnostics. We are going to import the model and its associated diagnostics that were just exported from Express into this Runtime Authoring tool, or RTAT. In this tool, we can either add in procedures or any external additional data that may be needed in order to perform troubleshooting, or so that it could be immediately included and published to enhance the DSI Workbench troubleshooting experience as desired. So we'll start by using a diagml import to actually import the file. Let's select the file that we exported, which would be this file here. As we bring in the diagml file, it quickly creates a project, designated by this snapshot image of the Express model. Because we are using a pre-generated model in the demo, we could discover any of the different views that were attached to the model for troubleshooting purposes. Additional images, photographs, test procedures, repair procedures, etc. can all be added in. The representation of the model design was brought in through diagml. Once we're finished in RTAT with the choosing and sculpting of any of the views and documents we wish to use for the troubleshooting experience in DSI Workbench, we can prepare a mechanism to capture all of our maintenance activities through the use of populating a robust database. We have a tab here where we can look at the database once we set up the database to use a database configuration file. The database formats that are initially supported are primarily SQL Server, MySQL, and Microsoft Access, but we are not limited to these. Any database format preferred can be simply added if needed. In our demonstration, we'll choose a connection to a SQL Server database. Notice that it immediately finds and connects to that database. Let's also add the project to the database. So this is taking the diagnostics that we exported from Express and moving to the database so it can start tracking everything using those diagnostics. Now at this point we are fully ready to begin our troubleshooting using DSI Workbench. For our demonstration, we are actually going to select a similar project that has been enriched with some photographs, documents, and any other useful information. To preview how this project would appear in DSI Workbench, we will invoke Preview in DSI Workbench mode here, where it's going to start a guided troubleshooting session in DSI Workbench by loading this project. Because this project was loaded to exercise the database, we are required to log in as a user in accordance with the user rights we previously set up for the usage of the database capability. In this demonstration, we will log in as a default user by selecting OK. At this point, because the database has been set up so that the technician is required to use troubleshooting tickets, which is an option, we must first enter or search for an existing ticket identifier, or we must create a new ticket. To create a new ticket, we select New and add a system or unit identification number. If we enter Unit 1 and we click Create, it automatically created a ticket number and immediately loads DSI Workbench, which is the tool environment that the technician would see on each workstation. Since DSI Workbench can be used in several selectable modes, we will be using the guided troubleshooting mode, which is where it prompts the user for the next most useful test in the troubleshooting sequence. Additionally, it is connected to the project database, so DSI Workbench automatically loads a ticket to track the troubleshooting experience. Notice that this ticket is ticket 1, which is what we just created. The results show that the ticket was opened and a session was started. There is an action log for the ticket, and it describes the status of the ticket here. Let's begin troubleshooting by performing some tests and show the effect upon the database and how it processes. So, if we fail the first test, we will be presented with a list of suspects. This list includes the additional insight that identifies the root failures that are called into suspicion by failing that specific test. To enrich the troubleshooting experience, we can add additional images of the fuse at the same time we can see the images in the original Express design, and the colored objects are part of the list of suspects. Additional views can include video procedures. If we select a video procedure, we observe the opening of a fuse box in an automobile and actually perform the replacement procedure. This doesn't just need to be a video. It could be a text procedure or any other information you would need to perform the repair. That particular video was accessed from the list of primary suspects, but really any of the hotspotted elements in the design, such as the fuse in the picture at the top right, can be accessed as well by right-clicking. If we were the technicians and knew the next test was going to take an hour, and yet we knew that another quicker replacement could be performed, like replacing the fuse, that would take far less than a minute, and we wanted to see if that would solve the problem, we could perform a repair immediately, despite not fully isolated to a fault group because we have a list of suspects. Then we would call up the remediation dialog. This is where we capture the corrective action performed against the equipment. The corrective action could be replacing a component, repairing a component, maybe something like detaching or attaching a cable, or calibrating something. Anything necessary to remediate the fault that you've diagnosed. If our initial remediation was the replacement of the fuse, we will enter that remediation action here and describe the corrective action to be to replace the fuse. Again, the corrective action can be any particular action and can be fully customizable. So now that we've replaced the fuse, it will record that transaction into the database, indicating the fact that we have performed a replacement. Let's select OK. After performing the replacement, we will need to retest. After we've performed the fuse replacement, we can notice that there has been remediation recorded in the database against that fuse replacement on the ticket. So now let's end this session and retest and restart the troubleshooting. And let's say that that particular remediation that we performed against the fuse did not resolve in a fix for our system. This will compel us to continue testing to fully isolate the problem. So continuing our troubleshooting from where we left off, let's fail the first test again. Now the battery is called into suspicion. If needed, we can look at a full procedure describing how to check the battery. Let's assume that this test fails. This will then isolate to the battery. Again, we can refer to the battery replacement procedure if desired. This demonstrates that we can have procedures against both tests and replacement that we can add to the diagnostics in the runtime authoring tool. At this point, we will replace the battery. Notice that we can see the original remediation that we did against the fuse. But now we're adding a second remediation, this one for the battery. Now we show two corrective actions that were performed against this system in order to resolve the failure in that particular diagnosis. Assuming the repair was performed, we will retest. So, we'll restart our diagnosis. Let's assume that this time my first test passes. This allows us to enter a fault resolution, which is when we've performed a remediation that has actually corrected our failure. So since the test passed, our fault resolution will indicate the fact that we correctly resolved the problem by replacing the battery. Here in the fault resolution screen, it's going to ask you what diagnosis was actually performed so it can be used for beginning any subsequent troubleshooting. This is the diagnosis I used for the fuse, and that was the diagnosis I used for replacing the battery. We will record the remediation that actually resolved the failure was the battery replacement and not the fuse. And what I'm going to do here is specify and say it was a component failure. These lists are fully customizable and can be set up for your preference. So we'll say the way we resolved it was by replacing the component. If it wasn't a component failure, if it was a manufacturing issue or a workstation issue, documentation issue, or whatever you discovered it to be, if you have categories for that, it can be logged and you can track that over history as well. So this resolution screen is where you actually specify what the problem was. We will record the resolution for this particular failure and end our troubleshooting ticket by closing the ticket. If we start a new troubleshooting sequence for another unit, serial number 2, we begin by creating a ticket for that system. Yet before we begin troubleshooting, let's view another new screen called the resolution history. This shows prior resolutions for the same set of faults that we are currently diagnosing. So let's assume that this new system has exactly the same fault as the prior system. So again, let's fail the first test. But what we can observe is when the first test fails, we are presented with a list of suspects from our diagnostic knowledge of the design. But what's new is a list of historical resolutions that have occurred for that particular diagnostic set of test results. Right now, our history, since we started with a brand new database, has only one repair in it. But over time, as we begin to build up a history, we can take advantage of trends. So, what's revolutionary is that, on the left, we have a prioritized list of remaining suspects directly from the design knowledge, while on the right, we have a prioritized list of remaining suspects based upon the empirical data accumulated from the troubleshooting sessions, both lists side by side. The resolution history can be biased by trends for any desired prior time and can be sorted by date, frequency, etc. And again, these lists shrink as you perform more tests because it's mapping them against the current diagnosis. Once we have established a mechanism to build a historical database into a process to track such details as ticket resolution, ticket times, test times, resolution by UUT, failure frequencies per time frame, how many of the failures were process related, how many were design issues, how many of them were manufacturing defects, etc. We can then split them up based on various things such as UUT, technician, date ranges, and then each of these bars are split up based upon a resolution type, which is user defined. The report generation capability in DSI Workbench is a very powerful way to get some quick reports all around a certain set of themes without having to go and do your own programming. However, because the data is contained in the SQL Server, MySQL, and Access database, it can also be easily adapted to be reused within any existing or relevant custom reporting structures. DSI Workbench provides a revolutionary approach to leveraging and repurposing existing diagnostic design knowledge right alongside the heuristic or empirical diagnostic data so that troubleshooting is embraced by the strengths of both approaches at any time during the production or sustainment life cycle of the designer system.